Computer. The block diagram of a microcomputer system is shown in Figure 6.1. The input-output unit consists of one or more ICs, which are used to control the data going in and out of the computer. The ROM or read-only memory and RAM or random access memory units consist of a number of special digital logic chips which can store programs and data. The small ROM provides some permanent storage and the RAM is used for temporary storage. Unlike the ROM, the contents of the RAM are constantly changing, but it only operates while the computer is switched on. The CPU, Central Processing Unit, is a microprocessor. It is the main part of the computer, which controls the rest of the system and performs all the arithmetic and logic operations on the data. Sets of connectors known as buses are used to carry the internal signals between each unit. The data bus is used to transfer data between all the units. The control bus is used to send control signals from the CPU to the other units. The address bus is used to send signals from the CPU which indicate the memory and I/O locations to be used. Computer. Computer. Data. Data. Program. Program. Permanent storage. Permanent storage. Temporary storage. Temporary storage. CPU. Central Processing Unit. CPU. Central Processing Unit. RAM. Random Access Memory. RAM. Random Access Memory. ROM. Read-only memory. ROM. Read-only memory. Arithmetic. Arithmetic. Microprocessor. Microprocessor. Microcomputer. Microcomputer. Arithmetic and logic operations. Arithmetic and logic operations. Connector. Connector. Data bus. Data bus. Control bus. Control bus. Address bus. Address bus. Question 1. Which component is used to control the input and output data of the computer? Question 2. Which memory stores information permanently even when the computer is turned off? Question 3. Which component is considered the brain of the computer, controlling other components? Question 4. Which bus is used to transfer data between units? Question 5. Which memory is used for temporary storage in a computer system? Question 6. What connects the CPU to other components to transfer internal signals? Combinational circuit. The decision-making circuits used in modern computers are mainly composed of combinations of digital switching circuits known as logic gates. Figure 6.2 shows the logic symbols and truth tables for some basic gates. The output of each gate depends on the combination of its inputs. This is known as combinational logic. The output for all possible inputs is shown using a truth table. The truth tables show that the output of an AND gate is only high, or logic level 1, when all its inputs are high. The output of a NAND gate, however, stays high unless all its inputs are high. The output of a NOT gate, also known as an inverter, is always the opposite of its input. Computers use ICs which contain a number of logic gates on one chip. An IC pinout diagram shows the arrangement of the gates and the function of each pin on the chip. See Figure 6.3. The number of ICs used in a computer, or the chip count, can be reduced by connecting NAND gates together to form other types of gates. See Figure 6.4. The number of components in an IC is indicated by its scale of integration as shown in Table 6.1. The IC shown in Figure 6.3 is an SSI device, but microprocessors used in computers are VLSI or SLSI devices. There are two common families of logic ICs used in computers. TTL, transistor-transistor logic, ICs use bipolar transistors to form each gate, whereas CMOS, complementary metal oxide semiconductor, ICs use field effect transistors. The different characteristics of each family determine which will be used in a particular computer. See Table 6.2. For example, TTL ICs are used in large, high-speed computers, and CMOS ICs are better for battery-powered portable computers. Combinational logic. Combinational logic. True table. True table. Inverter. Inverter. Pinout diagram. Pinout diagram. Scale of integration. Scale of integration. Question 1. What are the main components of decision-making circuits in modern computers? Question 2. What does the output of an AND gate depend on? Question 3. When is the output of an AND gate high? Question 4. What is the output of a NAND gate when all its inputs are high? Question 5. What does the pinout diagram of an IC show? Question 6. How can the chip count in a computer be reduced? Question 7. What does SSI stand for regarding an IC scale of integration? Question 8. Which logic IC family uses FET transistors? Question 9. Which family of logic ICs is better for battery-powered portable computers? Question 10. What type of ICs are microprocessors used in computers?